So good evening to all. Is the AV clear to everyone? Is the audio and video clear for everyone? Thank you. So in the previous session, we have discussed some of the problems on ratio test, root test, and limit comparison test. So in today's session, we are going to enhance our discussion over the remaining tests like Rabi's test, logarithmic test, Bertrand, and we are going to take two more tests, that is Gauss and integral test. So these things I am going to cover for today's topic. I think for each one, at the most 2 to 3 problems are enough for you to get an idea. The whole idea behind infinite series is simply, as and when an infinite series is given to you, you should be able to write the nth term un, and based on, you are simply classifying among the tests which are available to us, which is suitable here to check the convergence. That's it, right? So this is my idea to take some of the problems over these concepts. So I will give the test conditions as and when required. Okay? Right. So do you have any doubts with regard to the previous session? Thank you. So let us start our session. I am going to start the previous one as well as the new one. So let us take that summation n is equal to 1 to infinity. So 2 power n minus 1 by 3 power n plus 1. So here my intention is we should be interactive so that we have an idea on what problems we are going to discuss. So on seeing this problem, this is the nth term un clear. Now tell me which test we are going to apply here as per the knowledge considered to you. Are you getting that? So if I have written un 2 power n minus 1 by 3 power n plus 1. Yeah, since taking common is not that much practically useful, so you cannot apply the comparison test. If you want to apply whole power n, again you have a little difficulty there. So we will not apply the ratio test. So we will not apply the root test. Now we are applying the ratio test. So if you apply the ratio test, you calculate un plus 1 is equal to 2 power n plus 1. Sorry. So 2 power n by, yeah, please check on that. Is the terms correct? So let us calculate un by un plus 1. Equals to 2 power n minus 1 by 3 power n plus 1 into Now you are going to take the terms as common here. So if you take that, here 2 power n minus 1 gets cancelled, 1 by. If you take 3 power n as common here, 1 plus 1 by 3 power n. And here if you have common 3 power n here, 3 plus 1 by and 3 power n gets cancelled. Agree for this? Or otherwise, if you remain 3 there, it will be something different. Accepted the value. This is correct, right? The value, right? So here 2 power n minus 1 gets cancelled. 2 will remain here. So you can take 1 by 2 as common here. So if it will be written as 3 power n into 3 plus 1 whole by. If you take 3 power n here, 1 plus 1 by 3 power n, take, right? 1 by 2 into. So if you, yeah. So for these two terms, if you common 3 power n here, now agreed, right? So if you apply the limit for this, limit n tends to infinity, un by un plus 1, this will be equals to 3 by 2. Accepted? The limit value. So since the value is greater than 1, by the ratio test, we can say that it is convergent. Any questions? So please take a note of this. Then I will take one previous problem which is given earlier. After noting, please inform. Yes, we can apply un plus 1 by un. So then the limit value will be 2 by 3. Since it is less than 1, but ratio test is convergent. You can apply either of the conditions. So if the ratio gets reversed, the limit condition gets reversed. That is the only case here. Nothing more than this. Right. Have you finished this? Right. I will take the other one. The next one is 1 square into 2 square by 1 factorial plus 2 square into 3 square by 2 factorial plus the value is 3 square into 4 square by 3 factorial plus 4 square into 5 square by 4 factorial plus so on. This is the series given there. Now you are going to write the nth term un. How to write it? So for this problem also I am going to apply the ratio test. So you compute the nth term here. So it will be, if you observe all the first values 1, 2, 3, 4 so on, you can take it as n. And for the others 2, 3, 4 so on, you can take it as n plus 1. for each term, square is by default. So you can take n square into n plus 1 whole square by n factorial. Right? All of you agree? So if you calculate the next one, un plus 1, it will be n plus 1 whole square into n plus 2 whole square by n plus 1 factorial. So let us calculate the same thing, un by un plus 1. So n square into n plus 1 whole square by n factorial into n plus 1 factorial by n plus 1 whole square into n plus 2 whole square. Accepted all? Un by un plus 1. So if you cancel the terms, so n plus 1 whole square gets cancelled here. It will be written as n plus 1 into n factorial. So n factorial gets cancelled. So n square into n plus 1 by n plus 2 whole square. This equals to n square into n plus 1 by is that okay? Yes or no? Right. So if you apply the limit tends to infinity, un by un plus 1, what will be the value? Is it a finite value or infinite value? So here we need to say that since the value is bigger than 1, by ratio test it is convergent. Now what happens if you calculate un plus 1 by un, the limit value will be equal to 0. Since it is less than 1, it becomes convergent. Fine. So by calculating the ratio, the limit will vary. Here the limit is infinity. So if you flip the ratio, it will be 1 by infinity, the value will be 0. Accepted. Right. So you please take a note of it. Then can I erase this? Fine. So the next problem is test the convergence of 1 plus x square by 2 plus x power 4 by 4 plus x power 6 by 6 plus so on, where x is greater than 0. Right. So if you write the term un, so can we write it as x power 2n by 2n? Will it gives the whole series starting n is equal to 1, 2, 3, so on? Yes or no? If I write n is equal to 1, 2, 3, so on, will this term un gives all the values? If I take n is equal to 1, it will be x square by 2. If I take n is equal to 2, x power 4 by 4 and so on. So the nth term un significantly gives from this value onwards, right? So the first term is excluded here. Now what the thing is, sometimes the nth term un will not give the total representation of the whole series. So in such cases, what happens? We take this as 1 plus sigma un, the given series equal to. Now what happens if you calculate the nature of sigma un? If it is convergent, say, since it is a finite value, 1 plus finite value will be automatically finite. Agreed? So sometimes the nth term un will not give the whole representation of the series. So in such cases, we will omit the first or second terms usually. Always we will omit the first term. The rest of the terms will be given by the representation of un. Okay? Is that clear for everyone? So while writing on paper, we say that omitting first term 1, un is equal to x power 2n by 2n. Is this clear? Now the remaining procedure is as usual. So if you calculate un plus 1, this is equal to x power 2n plus 2 by 2n plus 2. Therefore un by un plus 1 gives us that x power 2n by 2n into 2n plus 2 by x power 2n into x square. So x power 2n gets cancelled. This is equal to 1 by x square into 2n plus 2 by 2n equals to 1 by x square into 2 plus 2n by 2. Clear? Accepted to all? Any questions? Now for this part, we apply the limit n tends to infinity un by un plus 1. So this is equal to 1 by x square into this value limit is nothing but 1 equals to 1 by x square. Accepted? Now based on this limit, we are going to say the convergence of the series. Now what happens? We say that if 1 by x square is greater than 1, it is convergent. So what does it mean? 1 must be greater than x square. Since you are taking all the positive values of x, by taking a square root on side, we say that 1 is greater than x, nothing but x less than 1. So we specify that as and when x is less than 1, the given series is convergent. Okay? So if x is greater than 1, the given series is divergent by ratio test. Now what happens if x equal to 1, the test fails, because if 1 by x square equal to 1, the limit value which gives that x square equal to 1 implies x equal to 1. Therefore ratio test will not hold here. So two situations are confirmed. One, when x is less than 1, convergent. When x is greater than 1, divergent. When x equal to 1, the test fails. Okay? Any questions? Now what happens to decide the nature of the series at x equal to 1? We are going to substitute x equal to 1 and we will verify whether it is going to become convergent or not. Let us do that. So can I erase this? Fine. So I will make space for the last part. So what happens if the limit portion 1 by x square is equal to 1, then the value of un by un plus 1 is equals to n plus 2 by 2n, and to decide the nature of the series here, how to go ahead? Any idea or clue? you can apply Rabi's test. That is agreed. Can we go for any other procedure here? Let us go for Rabi's test by default. That is always acceptable. So if you apply Rabi's test here, then what happens? The condition is n into un by un plus 1 minus 1. So n into 2n plus 2 by 2n minus 1 is equal to n into 2n plus 2 minus 2n by 2n. This equals to 2n gets cancelled. Accepted. N into un by un plus 1 minus 1, the condition of Rabi's test. Yes. All of you agree? So if you are able to apply Rabi's test, it is okay. Otherwise, we can make use of that. Can you apply any other test here? That also we can do. So what is the other way to decide here? Is there any idea for us? Now I say that you can go for other technique as, since we know that un is equal to x power 2n by 2n. Since x is equal to 1, at this point we are checking un is nothing but 1 by 2n. Say yes or no. Now I am going to apply the limit comparison test here. So I can say that if I take Vn is equal to 1 by n, then limit un by Vn is equal to 1 by 2, limit this is equal to 1 by 2 not equal to 0. Would you accept? See what I am doing. If Rabi's test holds good, it is okay. Apart from applying Rabi's test, I am searching for the other thing. I have already learned 3 more tests: root test and limit comparison test and general comparison test. Am I able to apply these tests here or not? That also I can take into consideration. So what happens, as and when the ratio test fails, usually the terms involving x, etc., after having this one, since you know what is un there, you can make use of the previous test also here. It doesn't mean that you should quit all the previous tests and apply the advanced test. That doesn't mean actually. Yes, Rabi's is failing. Since Rabi's is failing, you can apply other tests also, because I have so many other tests available there. It doesn't mean that after failing this test, only this test must be applied, previous will be neglected. That is not the case. We have several number of tests available. You are choosing which one is most useful at this point. We are always using the tests by means of trial and error, isn't it? As and when a series is given to you, by default you are applying this test. How you are knowing that this test is suitable here? There is no strategy at all. You can apply any kind of tests. But on observing the pattern of the terms, you are simply deciding that this will be useful for deciding the nature, that's all. Because earlier, on seeing that if a term contains whole power n, root test will be useful. There is a strategy and we are applying that. The same problem will be solvable for root test also and ratio test also. You cannot deny. So selecting these tests is one kind of trial and error method. One should remember that. Okay. I think I have clarified the doubt. So coming to this point, since the limit is existed and not equal to 0, by limit comparison test, both sigma un and vn converge or diverge together. So since sigma vn is equal to sigma 1 by n is divergent, we say that given series is also divergent. Fine. Is that clear? Any more questions, please? Or you stuck it at some point? So please take a note of that. After noting, please inform. Right. So the next problem is summation n is equal to 1 to infinity 2 into 4 into 6 into so on to n by this is the problem. So please take a note of it. Right. So what is un here? Un is equal to 2 into 4 into 6 into so on to n by 1 into 3 into 5 so on to n plus 1. So if you calculate un plus 1, it is equals to 2, 4, 6 so on to n into 2n plus 2 by 1, 3, 5 so on to n plus 1 into 2n plus 3. Agreed? Right. Now let us calculate the ratio here. So this is equal to comparing the terms here up to this part common here. So if we calculate the ratio, the value would be 2n plus 3 by 2n plus 2. So if you apply limit n tends to infinity, un by un plus 1 equals to 2 plus 3 by n by 2 plus 2 by n, limit of this value equals to 1. Therefore, ratio test fails here. So by default, we apply the Rabi's test only here. So let us calculate the Rabi's test. So we use the Rabi's test here. N into un by un plus 1 minus 1 equals to n into 2n plus 3 by 2n plus 2 minus 1 equals minus 2n minus 2 by 2n plus 2. 2n gets cancelled. This is equal to 3n minus 2n, so n by 2n plus 2 minus 2n minus 2, right? So if you apply the limit value, limit n tends to infinity, n into un by un plus 1 minus 1 equals to limit n tends to infinity, taking n as common here, 1 by 2 plus 2 by n, this is equal to 1 by 2. Right. Now what happens, since the limit value is less than 1, by Rabi's test, the given series is divergent. So what is the strategy here? By default, whenever the nth term is in the form of a product, we always use the ratio test. There is always accepted. As and when the ratio test fails, always we use Rabi's test. Now, there are some situations where Rabi's test also fails. In such cases, you can make use of the previous tests which are available, or you can go for the advanced tests too. If rabbit test is able to decide the nature, then it is okay. Fine. I think this problem clarifies the doubt. So let me take one previous year question. Can I erase this? Fine. So please ask your doubt as and when you have a question or doubt. I think it is also given in the previous year papers. I hope so. One plus x by 1 factorial plus 2 square x square by 2 factorial plus 3 cube x cube by 3 factorial plus so on. It is one of the UPSC previous year questions. After noting, you please inform. So here also, if you want to write the nth term here, un is equal to, you can say n so if you take n is equal to 1, x power 1 by 1 factorial. If you take n is equal to 2, n square x square by 2 factorial. N is equal to 3, 3 cube x cube by 3 factorial, like that. Accepted? And one thing here is, again we are going to omit the first term here, because the first term will not be given by this term expression un. So however, the given series can be written as 1 plus sigma un. So if sigma un is convergent, automatically the given series will also be convergent. Fine. So let us calculate the next value, un plus 1 equals to n plus 1 whole power n plus 1 into x power n plus 1 by n plus 1 factorial. So if we calculate un by un plus 1 equals to n power n x power n by n factorial into n plus 1 factorial by n plus 1 whole power n plus 1 into x power n plus 1. So this value can be written as n plus 1 into n factorial. So here you have n plus 1, that is n power n, x power n gets cancelled here, divided by, this will be written as n plus 1 into n plus 1 whole power n into x. Again, n plus 1 gets cancelled. This is equal to 1 by 1 plus 1 by n whole power n into x. Accepted? Any questions in simplifying the part? Yes or no? So if you calculate limit n tends to infinity un by un plus 1, this value equals to 1 by ex. Now based on this limit, we are going to say that given series is convergent or not. Now how the situation comes? If 1 by ex is greater than 1, convergent. It means that 1 is greater than ex, implies that x is less than 1 by e. Accepted? Now, if 1 by ex is less than 1, it is divergent, and the ratio test fails if x equal to 1 by e. Any questions, please? Yes or no? Right. Now, as usual, as and when the ratio test fails, immediately what you have to apply? Rabbit test, right? Since if you substitute x is equal to 1 by e, right, the limit part involves the symbol 1 by e. So we are going to apply the logarithmic test apart from the Rabbit test. Fine. So the technique of applying logarithm test is, if you calculate the limit, then if the limit symbol or limit value consists of the values e, then we are going to apply the logarithm test. Are you getting the idea, Alzi? Right. Now let us substitute the values there. So I will take the part here. So if you actually calculate un by un plus 1, from this part, it value is n power n by n plus 1 whole power n into 1 by x. Accepted? So I am taking the term before applying the limit. So I am excluding this, or you can take this also. And we are checking the condition at x is equal to 1 by e. Then un by un plus 1 becomes e into n power n by n plus 1 whole power n. Now if you apply the condition of logarithmic test, the test condition is given by n into log of un by un plus 1. For this, you are applying the limit. So we need to modify the term which is obtained there, so that application of limit will be very convenient. So how we are going to write this? Limit n tends to infinity n into log of un by un plus 1 is equal to limit n tends to infinity n into log of, the value is e into n by n plus 1 whole power n this value equals to e into, this will be written as n plus 1 by n whole power minus n. Accepted? It is of the form log of AB. So we are going to apply that limit n tends to infinity n into, so log e minus so limit n tends to infinity n into 1 minus n into log of 1 plus 1 by n. Please check on that. If you have any queries, you can ask. So while applying the logarithmic test, the simplification is important. So please take a note of this. Then I move ahead. So here, at this part, it is of the form log of 1 plus x. So if you consider the expansion, sorry, it is of the form x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus so on. This is the s best of the log x. So we apply the same thing there. So this equals to limit n tends to infinity n minus n square into x means 1 by n minus 1 by n square 2 plus 1 by 3n cube, so on. So this is equal to limit n tends to infinity. Here you have n minus n. You can take the values as n minus 1 by 2 plus 1 by 3n, so on. The value is given to give as n gets cancelled 1 by 2. Please check that. So since the limit value is less than 1, by logarithmic test, the given series is divergent. This is the conclusion. Now, so far, if you observe the strategy, by default, we use the condition ratio test. When ratio test fails, we apply Rabi's test. But the strategy here is, if the term un by un plus 1 involving the symbols e exponential, to cancel that, we are applying the logarithmic test. Okay? We will not choose Rabi's test. So let us take one more problem. It is also given in the previous year papers. Shall I continue? Fine. Is everyone clear with the approach or any doubts you have? Please tell. Any doubts to anybody? Okay. The series is given by 1 square by 2 square plus 1 square into 3 square by 2 square into 4 square plus 1 square into 3 square into 5 square by 2 square into 4 square into 6 square plus so on. This is the series given there. Please take a note of it. So if you write the nth term of the series, un is equal to 1 square into 3 square into 5 square into so on 2n minus 1 whole square by 2 square, 4 square, 6 square, so on 2n whole square. Right. So if you write the next value, that is un plus 1, it will be 1 square, 3 square, 5 square, so on 2n minus 1 whole square into 2n plus 1 whole square by 2 square, 4 square, 6 square, so on 2n whole square into 2n plus 2 whole square. So if you calculate un by un plus 1, the value is equal to, so up to this part the terms are common, so 2n plus 2 whole square by 2n plus 1 whole square. So if you apply the limit n tends to infinity un by un plus 1, the limit value is equal to 1. So please take a note of it. Then I will proceed. So by taking confirmation from everybody, then I will move. Accepted for the limit part? Everyone? Yes or no? You can do one more thing, that you can expand this by using a plus b whole square. Here also you can use the a plus b whole square format. Nothing wrong at all. So since ratio test is failed here, we are going to apply the Rabbit test here. So n into un by un plus 1 minus 1 you consider. So n into, so un by un plus 1, if we consider 4n square plus 8n plus 4 by 4n square plus 4n plus 1 minus 1 equals to n into 4n square plus 8n plus 4 minus 4n square minus 4n minus 1 by 4n square plus 4n plus 1. 4n square gets cancelled. So that will be taken as, so 8n minus 4n, 4n, so 4n square plus 3n by 4n square plus 4n plus 1. Accepted? Any questions? So if you apply the limit here, so you can take one more step, taking n square as common, 4 plus 3 by n by 4 plus 4 by n plus 1 by n square. Again, the limit value will be equal to 1. Agreed? Yeah. So ratio test in the earlier case failed. Rabbit test, here this case failed. Now can you say that the limit part, what you have calculated here, is that symbol E presented there or not? No, the symbol E is not there. Accepted? The limit value is simply 1 here. So at this position, when Rabbit test failed, we are going to apply the Bertrand test or De Morgan test, whatever you call it as. You can call it as the Bertrand test or the De Morgan test. So after finishing this problem and giving one more definition, I will give a rough ideology by drawing a simple picture. What test we are going to apply to decide the nature of convergence. Okay? Fine. So let us check the condition of the De Morgan or the Bertrand test. So can I erase this part? All of you noted? Thank you. So I am taking the part as let us write the part clearly. The test condition is given by n into un by un plus 1 minus 1 minus 1. For the whole, you are applying log n. So can you check once the condition what I have written, De Morgan or Bertrand test from your notes? Right. So we are going to simplify the part one after the other. So you have already calculated this part, n into un by un plus 1 minus 1. This part you have already calculated. We know this. It is nothing but 4n square plus 3n by 4n square plus 4n plus 1. Now in this you have minus 1 is there, then you are going to take log n. So let us calculate n into un by un plus 1 minus 1 of minus 1. So equals to 4n square plus 3n by 4n square plus 4n plus 1 minus 1. So 4n square plus 3n minus 4n square minus 4n minus 1 by 4n square plus 4n plus 1. 4n square gets cancelled. And this value equals to minus of n plus 1 by 4n square plus 4n plus 1. Accepted? Now here we are going to take the logarithm here. Therefore, n into un by un plus 1 minus 1 of minus 1 of log n. So minus of n plus 1 into log n by 4n square plus 4n plus 1. Now what happens? Let us take the values n as common. In the denominator I am taking n square as common. In the numerator I will take n as common. So equals to minus 1 plus 1 by n by 4 plus 4 by n plus 1 by n square into log n by n. Please check. I have taken n square in the denominator as common. Numerator I have taken n as common. So in n square the square gets cancelled. N will remain in the denominator. So that is the part left with that. So please give your confirmation. Any questions for anybody here? So if you apply limit for this part, it is equal to, here it is 0 minus 1 by 4 into 0. So if you apply limit n tends to infinity, log n by n, it is equal to 0 by L'Hospital rule. Accepted? You can apply L'Hospital rule, so the value will be equal to 0. So the total value is equal to 0. Therefore, by De Morgan and Bertrand test, the given series is divergent. That was the conclusion. Any questions, please? Yes or no? Fine. So can I take the other one? One less than 0? Right, right. 1 less than 1, the limit value is less than 1. So if the limit is less than 1, divergent, greater than 1, convergent, equal to 1, test fails. That was the condition, right? Yeah. So let me take the other one. So please take a note of the problem that one power p plus 1 by 2 whole power p plus 1 into 3 by 2 into 4 whole power p plus 1 into 3 into 5 by 2 into 4 into 6 whole power p plus so on. Is it visible the top? Fine. So if you write the nth term there, un is equal to, again, you cannot generalize the first term. So I am skipping this. For the rest of the part, I am writing the nth term. So it is going to take it as 1 into 3 into 5 into so on 2n minus 1 by 2 into 4 into 6 so on 2n whole power p. So the given series is nothing but 1 plus sigma un. Accepted? And we do the remaining procedure as it is. So take un plus 1. So 1 into 3 into 5 so on 2n minus 1 into 2n plus 1 by 2, 4, 6 so on 2n plus 2 whole power p. So if you consider the fraction, removing the common term there, it will be 2n plus 2 by 2n plus 1 whole power p. So removing n here, it will be 2 plus 2 by n by 2 plus 1 by n whole power p. So if you calculate the limit equals to 1. Please check on that. Any questions to anyone? Please ask. Now, since the ratio test is failed, we are going to apply the rabbits test here, right? So if you write the condition of rabbits test, this was the condition, isn't it? Now, is it possible to simplify that? Because you are going to apply the binomial expansion and you are going to cancel the terms after simplifying the expansion. Then you need to apply the limit, isn't it? Say, agreed or not agreed? Or do you have any other shortcut to simplify the expression? Say. So, since it is involving the power, to remove the power, we are applying the logarithm test here. Okay. So, do you have a shortcut method to simplify that expression which is inside there? No, right? So I am applying the logarithm test there because since power is there, so when you apply the power, the logarithm test, the power comes to the front. So I will take the log test here. So if you apply the log test or the logarithmic test, so the value is given as, if you calculate log un by un plus 1 into n, so n into p into logarithm of 2n plus 2 by 2n plus 1. Now you are going to simplify the expression there. Two plus 2 by n by 2 plus 1 by n. You are going to simplify the terms there. Am I correct in writing these terms? Okay. Yeah. So let us expand the values there. p into log of 2 plus 2 by n by 2 plus 1 by n. So if I want to apply the expression of log of 1 plus x, what is the modification I need to do there? So apart from taking 2s common, I can take 2ns common there, right? So this will be equals to n into p into log of, if you take 2s common here, it will come as 1 plus 1 by n, it will come as 1 plus 2 by n. So log of 1 plus 1 by n minus log of 1 plus 2 by n, 1 by 2n, you are going to get it as equals to n into p into, let us expand the terms there. If you are not interested every time writing n here, since n is not actively participating, you simply calculate only log of un by un plus 1. At the end, you can add the value n. So applying the term values there, you are going to get it as 1 by n minus 1 by 2n square plus 1 by 3n cube, so on, minus please check on that, 2n 2 square x minus x square by 2 plus x cube by 3 and so on. So x minus x square by 2 plus x cube by 3 and so on. So I am going to write the simplified form as n into I will write the final form 1 by 2 minus 3 by 8n plus 7 by 24n square since you can do the simplification on your own, I have straight away written that on cancelling n, this will be your answer. So please take a note of that. So if you are interested, I will write the simplification part also. Okay. So at this point, we take that by logarithmic test. If p by t is greater than 1, the series is convergent. That is, p is greater than 2. If p by t is less than 1, the series is divergent. That is, p is less than 2. If p is equal to 2, the test fails. So you please check on that. Fine. So if you take the first two terms there, you will get 1 by 2n. Since you are multiplying with n here, it will become 1 by 2. So straight away, I skipped one step here. I have written the form like this. Okay. Any more questions? To anyone? Any doubts with regard to this expression and finding the limit? Okay. So what you have done earlier, you have applied the ratio test. The test condition fails. Then since the term power p is involving there, I have applied the logarithm test. Logarithm test is also giving 50% of the valid conclusion depending upon p, because if p by 2 is, if p is less than 2, divergent, p is greater than 2, convergent, and p is equal to 2, the test fails. Now one case is remained with us, that if p is equal to 2, what happens? Now at this part we are going to make use of the second logarithmic test. So far we have used only log test, and we are going to use the second logarithm test here. Okay. Is the ideology clear? Yes or no? Now you are getting confused with this form. So shall I continue? Right. So if you calculate the value again, for p is equal to 2, n into log of un by un plus 1, the thing which we have calculated earlier, that will be equals to 2 into 1 by 2 minus, I think it is 3 by 8n plus 7 by 24 n square, 3 by 8n plus 7 by 24 n square, plus so on. So this will be equals to 1 minus 6 by 8 means 3 by 4n plus 14 by 24, that will be equals to 7 by 12 n square, so on. This is the value of n into log of un by un plus 1, in which I have taken p is equal to 2, the substitution. Now if you apply the test condition, the second logarithmic test, the test condition is n into log of un by un plus 1 minus 1 of log n. This is the test condition. So let us calculate one more term, n into log of un by un plus 1 minus 1. If you calculate the value, it will be minus 3 by 4n plus 7 by 12 n square, and so on. So for this whole term, you are applying the logarithm. So n into log of un by un plus 1 minus 1 of log n. If you consider the value minus 3 by 4n plus 7 by 12 n square, so on, of log n. So if you take n as common, so minus 3 by 4 plus 7 by 12 n and so on into log n by n. So for this, if you apply the limit will be equivalent to minus 3 by 4 into 0. Please check that condition. The second logarithmic test says that For this expression, you put -1 and take log n. For the whole term, you are taking limit n tends to infinity. So first of all, I have simplified n into log of un by un plus 1 minus 1, and I have multiplied with log n, and taking n as common, I can apply the limit very easily. That is the whole idea. So please check the limit condition again. Any questions? Since the limit value is less than 1, by second logarithmic test, it is divergent. At p is equal to 2. So what is the overall conclusion for the problem? For p less than or equal to 2, divergent, p greater than 2, convergent. That was the overall conclusion for the problem. Now, if you are clear with this limit part, I just want to write a strategy on applying these tests, how we are going to apply. So have you noted this? Any questions in this limit part to anyone? Say. Okay. Can I erase this then? So where you are applying the problems for which log test and Bertrand test are there, these are the difficult problems. Because remembering the test condition is difficult and applying the condition too. So this is the rough idea. Comparison test when taking n common or rationalizing. Then we apply, let us take the numbers for hierarchy, root test, whole power n form is there. Then we apply ratio test, usually product form is there. Then here we split the condition like this. So we apply Rabi's test. If Rabi's test fails, then we apply Bertrand test or De Morgan-Bertrand test. Then after applying ratio test, we apply logarithm, log test, E is there or power is there. Then after applying log test, you apply for second log test. Then after applying ratio test, we can apply the Gauss test that I am going to give later. So this is the whole strategy. Fine. Please take a note of it. So after noting this hierarchy, you will have a clarity of what we are doing for the given series is there. So always ratio test fails, then always we should use Rabi's test. Unless the limit is involving the power or the symbol E. Then if the symbol is there, we should apply only log test. If log test fails, then we further go for second log test. The usual norm is ratio test, then Rabi's test, then Bertrand test. And this is a special case that as and when ratio test fails, we apply Gauss test if the value un by un plus 1 is free of x and binomial form is available. So you can be expanding un or the fraction un by un plus 1 by means of the binomial expansion. It is very easy to apply. In such case, we use the Gauss test. Another one is if the sigma un involves the x, after applying a ratio test, straight away we can apply the Gauss test. Fine. So I will give the test condition of Gauss test also. That is very easy. The condition for Gauss test, if you want to know, if sigma un is there, contains x also, then apply ratio test, then apply Gauss test. If x is not there, straight away apply Gauss test. You please take a note of it. Then I will take a problem on it. Shall I continue by taking one problem on Gauss test, or let us wind up here? Please give your feedback. What about the others? Are you interested? Please tell. Fine. So can I erase this hierarchy? So take a note of the Gauss test, what it is giving that. So if we have sigma un, the series of positive terms, you can write un by un plus 1 is equal to 1 plus rho by n plus an by n power 1 plus lambda, rho comma delta are positive numbers, n is bounded sequence, then sigma un is convergent if rho is greater than 1, divergent if rho less than or equal to 1. So please take a note of it. One problem is enough to discuss over this concept. The test condition seems to be very confusing. Please understand that after calculating un by un plus 1, you are simply applying the binomial theorem and having an expansion there. In that expansion, you should have the compulsory terms as 1 plus 1 by n into some number, I am calling it as rho, plus 1 by n power something into some number. If this is the form is there, you are taking the coefficient of 1 by n. If the coefficient of 1 by n is greater than 1, we are saying that it is convergent, otherwise it is divergent. Okay? That is the whole idea. for Gauss test. The condition for every test, the failure condition sorry, for every test, the failure conditions are there. Initially, what I am saying, in order to apply the Gauss test, we should have the binomial expansion there. If you are unable to apply the binomial expansion, means Gauss test is failed, that's all. If you are able to expand un by un plus 1 in the form of binomial expansion, like 1 plus x whole power minus 1, 1 minus x whole power minus 1, like that. If that kind of expression is possible, fine. Otherwise, it fails. Okay. So have you noted this? Let us take one sample problem on it. The question given is, that is the condition. The series is given. So again, omitting the first term, I can write un as 2 square, 4 square, 6 square, so on, 2n whole square by accepted all, excluding the first term. I can say 2n plus 1 I can take, because all are, if I take n is equal to 1, 1 won't be there, right? 2n plus 1 whole square. So if you write the next one, un plus 1 2 square, 4 square, 6 square, so on, 2n whole square into 2n plus 2 whole square by 3 square, 5 square, 7 square, so on, 2n plus 1 whole square into 2n plus 3 whole square. So as usual, you calculate un by un plus 1. So taking the common part outside, the result is 2n plus 3 whole square by 2n plus 2 whole square. Please check that. So if you take n as common, it will be 2 plus 3 by n by 2 plus 2 by n whole square. So you can say one more part, or accepted. So if you apply the limit value there, limit is obviously equals to 1. Yes or no? Now in the denominator, can we apply the binomial form there? It is of the form 1 plus x whole power minus 2. Everyone agrees? So first of all, please take a note of this. Then I will going to do how we are going to apply the Gauss test there. After noting, you please inform. Right. So here, if I consider un by un plus 1, you can say it as 1 plus 3 by 2n whole square into 1 plus 1 by n whole power minus 2. The first term you are applying as a plus b whole square. So 1 plus 9 by 4n square plus 3 by n into, it is of the form 1 plus x whole power minus 2 The expansion is 1 minus 2x plus 3x square minus 4x cube and so on. So it will be 1 minus 2 by n plus 3 by n square minus 4 by n cube, so on. You accept it all? Now, if you multiply the terms with this, it is going to happen as all the values multiplied with 1. So 1 plus 3 by n plus 9 by 4 n square. Then if you multiply with 3 by n, it is going to come as 3 by n minus 6 by n square plus 9 by n cube and so on. If you multiply with 9 by 4 n square, it is going to take it as 9 by 4 n square minus 9 by 2 n cube and so on. Please check on that. Any questions there? So let me summarize this in a simple nutshell. You are going to write it as 1 plus 1 by n plus 1 by n square of something values in a simple form that I am going to say. Since the coefficient of 1 by n is 1 here, since the coefficient of 1 by n is equal to 1, by Gauss test it is divergent. You can check on that. I think I should have to modify that. Yeah, I just have to modify. I have written wrong here. So once multiplying with 1, I should multiply with minus 2 by n, right? All the values. Right. Since the session is closing, once multiply with minus 2 by n, to take that. That gives 1 by n. So I am going to take the same problem again in the next session. We will discuss on it. But this is the outline idea. Since the coefficient of 1 by n is 1, it is to be divergent by Gauss test. That's it.